Welcome to Chapter 7. This is going to be a quick video to remind us about, basically square roots and all that kind of stuff. Things that we're supposed to know about from other classes. And I know you know this stuff, but as we go farther and the radicals, we have to deal with them and we look at them and we turn them finally in next section into fraction powers. It's really good to understand the mechanics of what we already know. So basically, that's my intro to this. I almost didn't do a video for this, but I think it's kind of cool to do so. Okay, do you know what the square root of 25 is? Of course it is. It's 5. Why, though? Because 5 times 5 is 25, right? Or 5 squared is 25. Okay, so the square root of 25 is really the square root of 5 squared. And what do you notice about the square root and the square? Here's a new thing. I don't know if you know this. You can cancel those guys and get 5. That's helpful. Did I just turn this into something complicated? Can't you just say square root of 25 is 5? We got to go farther. We can do the same thing here. So for example, square root of 81, we know what it is. But you know what? It's the square root of 9 squared. Ooh, let's be fancy. Cancel the square and square root. You get 9. That's cool. Oh yeah, here's another one. The square root of negative 4 is equal to the square root of... kind of fizzles out. Because if you take minus 2 and square it, you get minus 2 times minus 2 is 4, not negative 4. There's no way to get there. So what this is this is actually not defined right now. Don't you like those words? Yet. It's not defined yet. So you can't put a negative under there, under a square root. How about this one? Well, it's equal to the square root of, watch this, 6 squared over 7 squared. Now, here's something else. It's the square root of 6 squared divided by the square root of 7 squared. Wait a second. You get to cancel those radicals with the squares, and you get instead, on top, you get 6. Downstairs you get 7. Did you know that it was 6 over 7? Well, 6 over 7 squared, that's another way to look at it, is 6 over 7 times 6 over 7. That's a giant 6. 6 over 7. And it's 36, folks, over 49, and that's a winner. But I did it differently. And you notice I snuck in another property of radicals, is that you can split them up a little bit. Meaning it was the square root of the quotient is the quotient of the square roots. Math people love to say things like that. Okay, that's an intro. Keep going. What's down here? Okay, you can always evaluate odd roots since odd powers are negative. That's what I'm telling you now. Negative 2 to the third is negative 8, so the third root of negative 8 is negative 2. And another way to write that could be, it's the same thing as the third root of negative 2 cubed, and once again cancel those guys, get negative 2. Okay, I'm doing that because we're going to run into variables also. If you know your stuff, then go for it. Hey, what's the cube root of negative 125? Students in my class will go, I'm going to use my calculator. But I'm going to do this. It's the cube root, and you're going to find out it's minus 5 times minus 5 times minus 5. So the cube root and the, you know what? Remember from, what's going to happen in the next section is you can write this as minus 5 to the 3 over 3. That's going to be in section 7.2. Forget about it. That also is another way. We can look at these as powers, but right now we're just canceling and saying the answer is negative 5. That turns into 1 though, doesn't it? And so on and so forth. 81, sometimes you can get lost. I say if you don't know it, you can always break it apart into factors. So 9 times 9. Some people get stuck there. You know what? We're dealing with a fourth root. So keep going. You've got 3, 3. Guess what? 3 and 3. This is equal to the fourth root of 3, 1, 2, 3, 4, to the fourth power. Okay. So you can cancel, and the answer is 3. That's because 3 times 3 times 3 times 3 is 81. 3 times 3 is 9. Another 3 times 3 is 9. And when you multiply, you get 81. And so on. You can verify that this is 2. And look at this one. This guy, maybe I verify it for you, but it is 2. I'll let you verify the following. This is equal to the fifth root of 2 to the 5th, so we get 2. This is equal to the 5th root of x to the 5, so we get x. Brilliant! So there's a pattern, right? If I've got under a square root, I've got a pair like 2 times 2 is 4, I can square root it. If I have under a 4th power, if I've got 3 times 3 times 3, I got 4 of them, I can 4th root it. And that's what we're looking for, that pattern. Okay, so, you know, things like this. This is weird, but am I going to do it later? Let's see. Yes, I'm going to do it right here. This is another one. You have like the cube root of 27 y to the 6th. Now look out, watch this. It's the cube root of 27. 3 times 9, and 9 is 3 times 3. Oh yeah, it's 3 cubed. Wouldn't that convenient? It's under the cube root. And you know what y to the 6th is? It's y to the 3 times y to the 3. Wow, that's cute. Can we cube root those? Yes. Because you can write this as the cube root of 3 to the 3 times the cube root of y to the 3 times the cube. Of course, you're going to be faster than this with your own shortcuts. And yeah, you come in and you go cube root of a cube, gone. Cube root of a cube, gone. Cube root of a cube, gone. Each one of those guys, you get 3 times y, and you get 3y squared. Believe it or not. Now look, this is what we just did. We say that 3y squared is the cube root of this guy. But now look, check it. 3y squared cubed is 3y squared times 3y squared times 3y squared. And of course, that's 3 times 3 times 3 times y2 times y2 times y2. Am I in beginning algebra? No. Yeah, kind of. It's all algebra. 27 y to the 6th. Ding, ding. Yeah. So what we're doing is we're going to take roots and try to find a shorter way to do these problems. Okay? What else is down here as we go through this? That's it. Cool. That's the end of that particular video. Basically, we get deeper and deeper into it to show you where we're going. You might have, oh, I'm supposed to go the cube root. What if it's not perfect? What if it's like 24? And then over here is x to the 5. Bummer. It's only a small extension to take us to section 7.3. And we're going to do it right now because we have some time. So 24 we all know is 4 times 6. I'm going to keep breaking. It's 2 times 2. It's a cube root, remember. Cubed, we need 3. And then, of course, 6 is 2 times 3. And there they are, Manny, Mo, and Jack, and a leftover 3. So I'm going to write this as the cube root of 2 cubed times 3 times, watch this trick, x to the 3, because it's cube root, and what's left over is x squared. Okay? We can cube root third power is 2, 3. We can also move them out of order. Cube root of x to the 3 times cube root of, and if I cannot cube root it, this and this, I leave them under the house. But of course, I'm going to cube root a cube root a cube. I get equals 2x. Do you see that? Cube root of 3x squared. Now that's what we're going to do. We did it in beginning algebra, but we're going to see more third and fourth roots in intermediate algebra. I hope you appreciate that last example. That really, if you see that, you are already, your mind is ready for 7.3. Okay, guys, we'll see you at the next video.